All right, so let's just kind of put it all together. Using measures of center and variation to make inferences about populations. What we're going to do is we're going to use the measures of centers and variability of this sample to make an inference about the heights of students in Amani's grade at school. So the first population is the girls at her school. The second population is the boys that are her schools at her school. And so what she's going to try and find out is how does the height of the girls compare to the height of the boys? Well, this is a dot plot, which means that I could use either mean absolute deviation, or I could use the median and the IQR to describe the data. Because of the fact that this is a dot plot, and because of the fact that both of them are symmetrical, I think what I'm going to do is I'm going to use, since I can use either one of them for this one, I'm going to use the mean and the mad. So just to kind of cut to the chase, I created a little table, and obviously I'm not going to show you the math that I put into finding the mean and the mad, but for the girls I found the mean was 62 inches and the mean absolute deviation is 8 tenths, and for the boys the mean is 66 inches and the mean absolute deviation is 1.4. So ultimately, what I want to do is I can take that information to make an inference, to make a generalization. So, generally speaking, based on the mean, I see that the boys are taller than the girls. And I said, and I went on to explain that I know that because the mean for the girls is 62 inches and the mean for the boys is 66 inches, 4 inches bigger. Also, the MAD indicates that most of the girls, because the MAD is lower than the MAD for the boys, that means most of the girls are closer to that average in height. You're more likely to find many, many girls with the same height, and it's going to be generally close to that average height, if not exactly that average height. Whereas the boys' height, since it has a bigger mean absolute deviation, not a lot but a little bit, they're more spread out. There's going to be more diversity in terms of height amongst the boys. Okay, here's another dot plot, and this one is Camden and Logan record the resting heart rates each morning for 10 days. The double dot plot shows their heart rates in beats per minute. Use the measures of center and variability in each of these samples to select the persons to which the statement applies. So looking over this again, they're dot plots. So that means I can use either the mean and mad or the median and the IQR. I see that they're both symmetrical, so still I can use either the mean and mad or the median and the IQR. In which particular case, so that's what I said, what measure of center should you use? Well, I could either use the mean and mad or the median, actually, and the IQR, since both are symmetrical. Who is more likely, so generally speaking, who is more likely to have a higher heart rate on a randomly selected day? Well, that would be Logan because as you can see, the dots fall farther to the right. Which data has greater variability? Well, I can see obviously Logan because the data is much more spread out. It goes from 67 to 75. So that's a difference of 8 beats per minute. Whereas with Camden, it goes from 63 to 67. So that's only 4. Plus, also, um, I can see that with Camden, his data are more clustered around the center, whereas Logan's are a little further apart. How can you use the dot plot to find the interquartile range? Well, keep in mind because we can do this. All we would have to do is we would need to find that dividing line between the lower half and the upper half, and then find the medians of the lower half and upper half, and then find the difference between the two. So just remember, even though it's not nicely laid out and everything, we still can very easily find it. All right. So use the measures of center and variation of this sample to make an inference about the daily participants for each adventure company. So we have rapid adventures up here, and notice how they're both box plots. And then we have Whitewater tours. One thing you will notice right here is this little asterisk. What that means is that particular data point is an outlier. Okay, so that is not part of what makes up the dot plot or what makes up the box plot. But just know that that one does have an outlier, which means that you can also see that the data is asymmetric. It's skewed. So that means that we would definitely have to use median and IQR to represent the center and the variation. So as I said here, use median and IQR because these are box plots and one is symmetric and the other is asymmetric. Now, overall, based on what I see, one thing I see is that the median for rapid adventures is higher than the median for whitewater tours. I also see that the range for rapid adventures is much higher and the IQR is higher than it is for the whitewater tours. So based on that information, I wrote this. Rapid Adventures typically sees more participants on any given day than Whitewater Tours. However, Whitewater Tours has more consistent number of people per day. Rapid Adventures has days that are slow, has slow has slow and busy days. Okay. So some days where there's not very many people there, and other days where there's a lot of people there. All right. Last but not least, the students of a middle school blog or of a middle school start a blog for their English class and contribute to it all year long. The double box plot shows the results for how often the 7th and 8th grade students contribute to the blog. What I want you to do is I want you to pause the video and I want you to answer the questions and then you can come back and check your answers. All right, glad you're back. Here we go. So we're going to use the measures of center and variability of these examples to samples to select all of the statements that can be inferred about the data. The students in the 8th grade posted blogs more often than the 7th grade. Well, as you can see here, particularly the box is much farther to the right on the graph for the 8th grade than it is for the 7th grade. And keep in mind, the lower end of the box since if we look at 15, we have the lower box, the upper box, and the upper whisker. So that's 75% of the data. If we look at 17 on the 7th grade, well, 15 on the 7th grade, we find that that's halfway between the upper box. So we can estimate that there's approximately 35% that is 15 or greater versus 75. So obviously the 8th graders blog more. So then if the 8th graders blog more, then the next statement is not true because it's not the 7th graders that blog more. The amount of variability for 7th graders is greater than for the 8th graders. So that I want to look at the range or the IQR. Well, even if I look at the range, I notice that the range is the same. So I'm going to definitely look at that IQR. And I see that that IQR is bigger for the 7th grade than it is for the 8th grade, which means that there is more variability. Okay, they're not as clustered to the median. All right, every student in the 8th grade posted more blogs than every student in the 7th grade. Well, that's obviously not the case because we have overlap. What that means is that The seventh grade and the eighth grade share a lot of the numbers. They have the same numbers. In fact, both of them have 0 to 30 in them. Whereas if we had one that had 0 to 30 and the other had 35 to 60, there would be no overlap whatsoever. So we could say that the fourth one is not true. And then lastly, 25% of the eighth graders posted at least 25 blogs throughout the year. So looking at that on the eighth grade, I see that the between 25 and 30, that's one whole whisker. Each part represents 25%. So that one whisker represents 25%. So that is true. All right, so what I want you to do is I just want you to do the best that you can on the workbook page. Remember, the workbook page is to make you think, have that productive struggle. Um, it's not for you to get it right, necessarily to get it right or get it wrong. It's to identify what you can do and to identify what questions you need to ask. Okay? All right, catch you on the flip side.